All right, a very good evening, I guess, in Malaysia right now. I'm SEETA from University of Science Malaysia. Today, I'm going to present my research with the title Fabrication and Characterization of Seaweed-Based Biodegradable Film Incorporated with Plant-Derived Bioactive Compounds. Okay, so these are the introduction, the contents. Okay, I'll talk in details about these contents. So before I talk in details about my results and discussion, let me just give you a brief introduction about my research. The production and utilization of plastic have been increased enormously to about 300 million metric tons per year worldwide. Only less than 10% of total plastics are being recycled. I repeat, only less than 10% of total plastic are being recycled. So what happened to the remaining plastic after usage? It basically accumulated in the environment. Because plastics are not biodegradable and it can generate significant sources of environmental pollution, harming wildlife when they are dispersed in nature. So with that, this is the justification for my research. Basically, synthetic plastic are made from fossil fuels. So the depletion of fossil fuels can definitely interrupt the development of synthetic plastic. And just because the synthetic plastics are non-biodegradable, so it gives harmful effect to the environment and health. So that is why development of biodegradable plastic from renewable sources like biopolymer is important to ensure plastic are biodegradable and more compatible with the environment. But we have to remember that biopolymer has certain limitations, like non-availability of high biomass and difficulties involved in cultivation. That is why in my research, fabrication of biodegradable bioplastic from seaweed has been done, but seaweed has relatively poor mechanical and water barrier properties compared to non-biodegradable plastic. So that is why the neem leaves is incorporated in the seaweed matrix to enhance further the properties of seaweed-based film. So with that, these are the objectives for my research: to extract neem leaves compound using ethanol solvent extraction method, to fabricate seaweed-based biodegradable film incorporated with different concentration of neem leaves extract, and finally to study the effect of different concentration of neem leaves extract on the morphology, barrier, mechanical, biodegradability, and thermal properties of the film. So this is my schematic diagram, as you can see. So I will talk in details. Basically, there are two stages for my research. The first stage is, First stage is preparation of raw materials. So where neem leaves and raw seaweed are the raw material. Basically, for red seaweed, I used the species of Caperhicus alvarezi. So neem leaves is extracted from using ethanol, and the last form is base form. Okay, the second stage is development and characterization of biodegradable film, where seaweed and the neem is incorporated in seaweed matrix, and glycerol is added as a plasticizer to fabricate seaweed neem biodegradable film. So, and then the film is characterized based on the mechanical properties, barrier properties, thermal, biodegradability, and lastly, the morphological using scanning electron microscope. So with all this, you can I actually can identify the film with the optimized property for further packaging applications. So these are the results. So you can see here the extraction process using ethanol solvent, and the yield that I obtained is 5.6%. So for the second stage is the fabrication and characterization of seaweed neem film, where on my left-hand side, you can see the images of fabricated film. I use a range of neem leaves concentration starting from 2.5%, 5%, and 7.5%. So seaweed film is the control without any neem leaves incorporated. So from the characterization results, firstly is the mechanical. You can see the addition of 2.5% of neem leaves in until 7.5, until up to 5% neem leaves is actually it increased the tensile strength. But at 7.5%, it actually decreased the tensile strength value. Elongation at break also increased. Okay, this might be due to the interaction between neem leaves and also seaweed hydroxyl group, that is hydrogen bond, so which enhance or strengthen the film structure and enhance the tensile strength. Whereas at the 7.5%, which is a very high neem leaves concentration, there is agglomeration. Later I will show you in SEM, scanning electron microscope, there is agglomeration and holes, so that's why the tensile strength is reduced. So the next one is the barrier properties. I did two different barrier properties tests. One is water vapor permeability. The other one is oxygen permeability. So water vapor permeability, as you can see, the water vapor permeability also decreased because of increase of hydrophobicity. As I told you, there's hydrogen bond between seaweed and neem. So that is why the hydrophilicity of the film reduces. When hydrophilicity reduces, water vapor transfer reduces and water vapor permeability reduces. So this shows a very good water barrier property. Whereas for oxygen permeability also decrease as the concentration increased up to 7.5% of neem leaves. This is because addition of neem leaves can increase the film thickness, and there is hydrogen bond, which can decrease the oxygen permeability. So that is why the oxygen barrier is very important and it increased. So this is for the barrier properties. Then the next one is the thermal properties. I use TGA, which is thermogravimetric analysis to analyze the decomposition and thermal stability of the film. So up to 5%, there is actually increased of thermal stability. So you can see the T onset, T on, and T maximum increased at a higher neem leaves concentration. This is because the addition can cause hydrogen bond, and also the thermal stability increases. Okay, so next is the biodegradable test. I use soil burial test. There is weight loss for the soil burial test, and it's actually both are hydrophilic, the neem leaves and seaweed. So that is why it can enhance the biodegradability of the film. Okay, lastly is the surface morphology. There is good dispersion up to 5%, but 7.5%, as I explained, the tensile strength reduces. There is groove and also holes in the film morphology. So with this, from the characterization, the film with the 5% neem leaves extract shows the most optimized film property, especially on the mechanical and properties. So this is a conclusion. So basically, the neem leaves can be potentially used as packaging material for the later. There is a lot of tests that I did, which I didn't show in this presentation. So with that, thank you very much for your attention. So back to you, Chairperson.
Thank you very much, Doctor, for your wonderful presentation. I really appreciate your work. And kindly, if the audience have any question for this presentation, anyone, please. I assume there is no question for you, Doctor. Once again, thank you very much.